Example 2, convert each entire radical to a mixed radical in simplest form. So we've kind of been practicing this when we did our quadratic formula. So the first one's 200. And again, try to pick the largest perfect square that fits into there. What's the largest perfect square that divides into there? 100. Good. Put your perfect square first. Put your leftovers second. They get their own square roots. Okay, we can give them their own square roots because it's 100 times 2. It's not adding. So if you had adding in there, 100 plus 2, you can't give them their own square roots. But as soon as it's multiplying or dividing, it's fine. This part here, we evaluate. We just take a 10. So this is 10 square root 2. Okay? All right, ones with variables. Okay? So the variables are often the easiest to look at if we group them up. Okay? So I'm going to show you this one with the 100 a little bit differently so you can see where I'm going to get this next step from. I can rewrite 100 as 10 squared. Okay, so that's why this is really happening. You did just know I said what's the square root of 100 and you said 10, but really it's because it's 10 squared and the square root are opposite. So if we have a fourth root over here on B, if we have them in groups of 4, then, and we're 4 3 in groups of 4, then that's how they get pulled out. Okay, so I have 9 C's here, so I'm going to split them up into groups of 4. Okay, I have C to the 4, I have another C to the 4, and my last one is just a C to the 1. So they get their own fourth roots, okay, but it's C to the 4 times C to the 4 times C to the 1 because you would have added those all together to get 9. So then what's happening here is this one cancels with that. This root cancels with that exponent. You have a C times a C out front, and then you still have a fourth root of C left. You don't have to show the 1. Okay, and then what does the part out front become? You would leave it as C times C. You write it as C squared. Good. So this is C squared. That's by the fourth root of C. Okay, it didn't ask us to come up with the restrictions on the variable, but we could. You could do it back up from the original. Okay, it's an odd root, or sorry, it's an even root with the 4, so you can only fourth root positives and 0. So because of the 9, we have greater than or equal to 0 for C. Or you can just look here. This doesn't matter because it's not under the radical. Excuse me, that's not under the radical, but this part is. And here you could definitely see how C would have to be greater than or equal to 0. So either way, you can look at it at the beginning or at the end. It shouldn't change. Okay, it should be the same at the beginning as it is at the end. All right, and then the last one here for C, you have the square root of 48y to the 5. So we can treat the numerical value separately from the variable value. 48, what's the largest perfect square that divides into 48? Anybody know? 16, good, and it's the 16 with the 3. So this is a 16, it's a perfect square. I put the 3 over here because I'm going to put perfect squares for my numbers here and my letters here because they're all going to come out of the square roots, right? So 16 times 3. Y to the 5, what do I want for group sizes? I want y to the 2 because this has an index of 2, I just don't see it. So I have a square root of y squared, I have another square root of y squared, and then I still have 1 left over y. So these ones, square root of 16 becomes a 4. Square root of y squared, square root of y squared, those cancel, so you just have y times y, which is y squared. And then these guys, you can combine them back together if that's all that's left, and they go underneath as a 3y. Okay, restrictions on this variable. It's probably easier to look there. Y has to be, can it be positive? Yes. Can it be 0? Yes. Can it be negative? No. Okay. So y is greater than or equal to 0, and y is an element